Okay, being the stubborn person that I am, I'm going to try to set the session. Perubahan. Guna. Okay, so I'm going to click make now. Okay, let's see whether this thing works or not. Okay, so now kita dah start. Okay, allow access. Okay. Okay, I have to join. I have to join. I have to join. I have to. Okay. I have to join. I have to join. I have to join. Okay, so basically we are testing this. Okay, next thing I'm going to do, I'm going to try to see whether I can pull the my PowerPoint. Okay, so my PowerPoint will be from the desktop. There's supposed to be a button here that I click. Okay, there's supposed to be a button here that I click that will allow me to pull down the screen from the back. Okay, so semua orang saya akan senyapkan dulu sebab saya testing. So minta maaf lah ya, saya tak boleh cakap. Alright, okay, so let's try this. Let's try this. Okay, I do not know how this thing works. Sebab tadi masa sebelum you all masuk, ada butang untuk I nak type. Okay, so sekarang ni you all dah masuk, I dah tak boleh nampak butang Okay, so the lecture I'm going to cover is this lecture. Okay, I'm giving you the files. Saya tak kata code, saya bagi free saja. Kalau nak saya bagi sari yang dengan okay. So sekarang ni dia punya sistem ni pelik sikit, saya minta maaf. Okay, let me figure it out. Okay, location, saya akan tukar location. Oh, tak boleh lah, dia kena upload daripada OneDrive saja. Okay, so nampaknya saya tak boleh nak ini, tapi tak apa, kita akan pergi ke alright so oops. Okay, jom kita cuba. Okay, I am supposed to go to desktop. Desktop tu dia melompat. Okay, let's go screen desktop. Oh, tak ada. Okay, so saya akan buka PowerPoint. So I'm going to give you a normal lecture on GLM. Okay, one thing about this thing, everything becomes slow, glacial speed. Okay, so I'm very sorry about this. Memang slow gila. Nak nunggu ke apa-apa buka pun tak boleh, slow. Ini boleh lah nyanyi lagu Hilas, Hilas, Tulil Firdaus. Alright, so I'm seeing the PowerPoint now. Okay. Okay, hopefully you can see this. Okay, so in short, we are supposed to cover general linear model, GLM. Dalam general linear model ni, there are three possible models. You got the univariate, you got the multivariate, and the repeated measures. So what is so great about GLM? Basically, it is a flexible statistical model which incorporate many analyses, so that if your data is normally distributed, you can use it for analysis, and it does not matter whether your independent risk factor is categorical data or continuous data. So they have a name for the categorical data, they call it as factors. For the continuous predictors, they are called covariates. So GLM ni roughly you got three types: univariate, multivariate, and repeated measures. So of these three, the one that is the most important for us is repeated measures. Why? Because the univariate one we already covered. It is similar like multiple linear regression and general linear regression. For the multivariate model, we rarely need to do that. Okay, but I will also cover that. Okay, but the one that we tend to require to do the most is repeated measures, because we tend to do a lot of repeated measurement. Okay, so for example, univariate models, you have one dependent variable, which is continuous data. The outcome could be categorical predictors only, okay, which is ANOVA. So examples, you want to compare the weight of the baby between mothers who are working in the as a housewife, mothers working in the field, and mothers working in the office. So we got three categories and the weight of the baby, and for that we do ANOVA. So that is one type of univariate. Or continuous predictors only. For that is regression, multiple linear regression. So the one that we are going to cover in this course is combinations of categorical predictors and continuous predictors, which is UNCOVA. Okay. For that, we're going to learn. For multivariate, we need to accommodate two or more independent variables. So the outcome is two or more. Okay, so the outcome is two or more. And but the predictors could still be the same like before: categorical predictors only, continuous predictors, or combinations of categorical predictors and continuous predictors. The one that we tend to use the most is repeated measures. Why? Because we like to do tests before and after, and we tend to take many different measurements many times. And yet at the same time, you've got two groups: treatment group and control group. So when we do like this, we need to do GLM, repeated measures. So for the analysis, to do repeated measures is simple. You just click analyze, general linear model, univariate, or multivariate, or repeated measures, whatever you need to do. Then we have the example data. This one we show you. I know it's not clear, but basically we're trying to show you on the PowerPoint. Click general linear model, then you select repeated measures. Okay, so now we're going to show you for the GLM repeated measures how it is done. Okay, repeated measurement analysis GLM, ataupun ANOVA repeated measures, some people call it like that. Okay. So for the GLM, it is the simplest repeated measurement analysis with the pre and post type of study. Okay. So usually if we have only 2 time points, before and after, and there is only one group, we can do the PAT-T test. But in the real life, we have many situations where there are many groups, and we do the data collection many times. Let's say for every 3 months. Okay. So what is the common techniques that we tend to use? Okay. Usually, since we already have 2 or more groups, okay, now you need to do the analysis. Okay. For example, we have mean response over time. Okay. So instead of taking one the final measurement, we take the mean response over time. So we take if we do 3 measurements, we take the mean of the 3 measurements after the intervention. Or we do a separate analysis at each time point. Okay. So what do? Time 1 versus baseline, time 2 versus baseline, time 3 versus baseline. Okay. By each group. Okay. So this is not suitable also. Some people use area under the curve, minimum and maximum values, or time for you to get to the required maximum values. Okay. There's a lot of error here right now. They say that I got network problem. Sorry. Okay. So to avoid all that, let's have a look. This lecture is based on the PowerPoint. This lecture is based on the notes from Y Chan. Okay. So we have 2 groups. This group consists of confident people and consists of not so confident people. Okay. Who are the confident people among you? Very highly confident. Okay. Maybe Ehsan highly confident. Maybe Hanan very highly confident. Zul lieutenant kenal kan? Kenal already kan? So must be highly confident. But then among you, there are some people who are less confident. So we want to see among these people who are more likely to make mistakes, the low confident people or the high confident people. Okay. So we give them the test 4 times. Trial 1, trial 2, trial 3 and trial 4. So what is our interest? Is there a difference in number of errors made between the high and low anxiety subject? Over time, you got practice many times. Will you make less errors? Okay. So this is what we call is there a change over time? Is there a reduction of number of errors for over time? Okay. There are some of you who are interested to know whether I can add people right now. Okay, I just get up from this page. Yeah. Okay. Aizul. Aizul. Okay, jom. Okay, ada some people minta saya add dia balik ataupun dia ni ada some problem sikit. Okay. Okay. Sebab some of you tak register pakai nama betul. Jadi bila saya add, dia tak keluar dalam sistem. Okay. So tak mahulah yang saya tak add. Saya akan, tapi benda ni semua saya rakam. Jadi kita akan upload dekat Facebook lepas ni. So gambar Zul keluar, gambar siapa ni comel keluar, dia akan masuk dalam video tu nanti. Okay. Sekarang saya tak tahu, tiba-tiba dia keluar dia keluar post kata boleh rekod. Julana pandai dah boleh rekod. Tahniah. Hai Zul. Lawa rumah. Boleh ziarah rumah lepas ni. Sekejap saya tengok balik benda ni. Okay. So you all boleh rekod You all boleh rekod, gunakan sendiri. Dekat butang you dalam tu ada butang rekod. Okay. Tapi saya memang rekod pakai Camtasia. Jadi saya akan upload the whole thing ni ke dalam YouTube. Sekejap, apa ni? Tadi ada Rohani minta add dia. Okay, saya tunjuk ni, kamu boleh nampak skrin ni kan. Saya klik manage team. Okay. Siti Rohani, nama dia Siti Rohani. Okay, saya type for members. Add member. Dia boleh nampak? Okay. Saya type Rohani. Siti Rohani Nurumal. Okay. Yang keluar Siti Rohani Nurumal yang 95136. Okay, saya add. Okay, dia kata dah masuk dah. So cakap Siti Rohani Nurumal, dia punya membership pakai yang ID masa student dulu. Okay. Okay, sekarang ni aku nak keluar boleh tengok muka Zul, aku nak tayang aku punya screen balik Okay Zul.
Okay bro.
Alright. So sekarang ni, okay, saya bila stop dia hilang. Alright, sekejap Okay, mana saya punya PowerPoint. Okay, ni dia. Okay, so ini yang kita cerita tadi. So bila kita analisa pakai general linear model repeated measure, senang je. Kita masukkan faktor yang kita nak kaji. So biasanya faktor tu kita nampaknya faktor 1. Saya suka gunakan apa orang kata tu sorry Zul, aku kena mute kau. Suara keluar sekali lah. Okay, boleh. Alright. Saya tak tahu macam nak buat ni. Alright, namailah. Okay, so sekarang ni analyze, bila kita klik dekat within subject factor name, kita akan gunakan benda yang kita kaji. Contohnya, kita nak kaji pasal error, kita instead of tahu factor 1, kita tahu error. Berapa level, kita ada 4 kali ujian, kita akan buat 4 kali. Okay, so kita akan masukkan sini error kat atas, followed by number of level, followed by alright. Okay, jom kita pergi next. Oops, sorry. Okay. Jadi saya tak tahu yang saya mute ni mic saya ke mute mic orang lain. Sorry. Okay, saya ulang balik so kita akan klik letak tu, kita akan buat kajian tentang error, kita letak 4 sebab kita ada 4 level. Then lepas tu kita akan proceed with the analysis. I'm very sorry, kejap-kejap mic I ter-offkan mic I sendiri. Very sorry. Alright. Okay. So ada 4 level. Okay. So lepas tu kita klik add dan kita klik define. Lepas tu kita kena tarik daripada belah kiri tu, trial 1, trial 2, trial 3, trial 4, tarik ke kanan. Lepas tu ditanya kita nak ukur apa, kita nak kaji tentang level of anxiety antara 2 group. So kita ada 2 group tadi, high anxiety dengan low anxiety. So kita masukkan dalam tersebut. Okay, next. Kita akan dapat result macam ni. So result pertama ni yang kita tunjuk ni adalah test between subject difference. Dia mengatakan bahawa ianya tidak signifikan. Apa yang maksudnya ini? Ini adalah secara purata. Kalau kita ambil, kita jadikan trial 1, trial 2, trial 3, trial 4, kita ambil sebagai purata, kita dapati secara purata ini tak ada beza. Okay. There is no difference in terms of mean number of errors made over time between the low and high anxiety group. P-value tak signifikan, 0.460. So, kita nampak ni, masalah yang paling besar dia adalah between subject difference. Okay, between subject difference. Okay, so let's look at the next one. Sekarang ni kita nak buat test. Now we want to do the test. So what we do? Now we are going to put anxiety dekat we want to display the means based on level anxiety high and low. So we are going to do the test. The test. So we got few choice: LSD, Bonproni, and Sidak. Okay. So in this case we will use Bonproni. Okay. So now we got the answer. The mean anxiety the number of errors, based on level of anxiety. Low anxiety errors dia 9.5, high anxiety errors dia 10.4. Okay, so high anxiety ni make slightly more errors compared to the other group. So is it significant or not? We don't know. Okay, let's go next. Okay, so we look at the difference. You can see there the p-value not significant. So there's no difference in terms of errors between the high anxiety group and the low anxiety group. Okay, so now we are going to do the next one. We do the next one. We're going to get the plot. They are going to get the plot. We just click on profile plots. We say horizontal axis trial and separate lines for anxiety. Kenapa trial? Kita set yang untuk trial kat atas, anxiety kat bawah. Okay. So anxiety ni is the grouping. So we're going to get separate line for the anxiety group. So now you can see here in the line, you have the high anxiety, the straight one. The dot one is the low anxiety. So the low anxiety, high anxiety, they are about similar. They are about similar in terms of number of errors. So what does it show? It shows that both groups does display a reduction number of errors over time, as you can see from the figure 1 just now, the earlier figure. The reduction trend is significant. Yes, in terms of change over time, both are significant. But in terms of difference between the group, they are not different. So where do we get this? Okay, so we get it from here. So we got two approach, either univariate or multivariate. Doktor tadi dah kata repeated measures. Yes, dalam repeated measures tu ada dua jenis, ada univariate, ada multivariate. So when you're using the univariate, you have to look at the Mauchly sphericity test. So Mauchly sphericity test, if you want it to be not significant, so you can see here the p-value is not significant, 0.053, then we can use the Mauchly sphericity test. If it is significant, then we have to use any of the three or the multivariate version. So you can see here, looking at the Mauchly sphericity test, you can see here for the trial, is there a change? When we say trial, is there a difference? Is there a change over time? So the change over time, yes, it is significant, 0.000. So over time, the number of errors become less. Is the change over time the same or different between the two groups? This one is under trial and anxiety. No, it is not different. The p-value, it is not significant. So they are about the same. Okay. So that is the meaning of this test. Okay. So that is univariate approach. Sometimes univariate approach is not valid because of the Mauchly sphericity test, p-value less than 0.05. So you have to use multivariate. So for the multivariate, you look at the box test. The box test look like this. If the box test, the p-value is larger than 0.05, you are okay. You are okay. Then you can use the multivariate test. So for the multivariate test, same thing. We got so many here. We got Pillai trace, we got Wilks lambda, we got Hartelling trace, we got Roy's largest root. Any one of these can use. Okay, but what do we use? We tend to use Wilks lambda. Why? People are familiar with the names of Wilks. So we tend to use the word Wilks. So Wilks lambda, is there a change over time? Yes, it is significant. P-value less than 0.05. Is there a change over time? Is the change over time same or different for the both groups? They are the same for both groups. Okay? They are not different. P-value is not significant. That's why they are because they are the same. The change over time is the same for both groups. There is no time and group interaction. So in our case, we can use both univariate and multivariate. So which one should we use? Okay. So now we are going to show you how to decide. Okay. We will show you how to decide. First, we will try to use univariate. If univariate not valid, we go to multivariate. If multivariate not valid, then we go to univariate adjusted. Okay. So you can see here, we look at the sphericity test. If the sphericity test say it is valid, then we use the univariate test. We use the Mauchly sphericity results. If the multivariate test is significant, we cannot use Mockley. So we have to use multivariate. So we use multivariate. If multivariate not valid, then we use the adjusted univariate. Okay, that's how we decide. Okay, and this is how when we do it ourselves, this result is quite similar. And with that, we will stop. Just to show you, okay, that in fact this thing is based on the mean this ANOVA. Okay, what we did is now, if we do the between subject effects test, okay, if we do between subject effects test, we get the 0.460. Mana dapat 0.460 ni? Because we take when we take the mean of everything and we come up with one subject, so mean of mean of errors. So we take number mean of errors between the 4 trials. We do ANOVA test between the high anxiety group and low anxiety group. We get the p-value of 0.460. Okay, and with that kita tamat untuk hari ini. So now I'm going to stop the session. I think I have achieved what I wanted to do for today, and for that it is very good already. Okay, so thank you very much. Okay, macam mana aku nak stop ni? Okay. Sekarang saya tak tahu macam mana nak keluar dari conference. Best kan? Syarah tak tahu dia. Okay, this one kot. Hang up. Alright, thank you. Okay, so this is the data that we showed just now. So we have 12 subjects. There are 2 groups, high anxiety and low anxiety group. So we have the number of errors made by them for trial 1, trial 2, trial 3 and trial 4. So I'm going to show you how we do GLM repeated measures for these 2 groups. So we click analyze, generally the model, repeated measures. Okay, so what we are studying, we're studying number of errors. So we put error. Instead of trial, I put error. Why? Because so that I remember the study is what error. So we have 4 levels. Okay, so we click this one, we click define. So we're going to select the number of errors that happen in trial 1, trial 2, and trial 3, and trial 4. So we transfer it here. Okay, what we are interested in? We are interested in the level of errors within the 2 groups, the high anxiety and the low anxiety group. So we put in the anxiety group. Okay, so for the analysis, okay, we have the model. Model is the default one. Okay, full factorial. Contrast, don't need to do contrast. Okay, plots, what plots we want? We want to have separate line for the anxiety group, the high and low anxiety group. We want it to plot it over time based on number of errors. So error. Okay, click add, click continue. Okay, post-hoc. You want to see the post-hoc by level of anxiety. So we put in the anxiety. So you can have, if the data we expect to have equivariances, we put one of these, Bonferroni, CDAX, and so forth. So let's just take Bonferroni. Okay, click continue. We're not going to say anything. Options. Okay, you need to display the means, means of error over time. Okay, so means of what? Okay, so you can say you can want to see the number of means of error over time. Is the number of over time is the number of errors same or different? Okay, so you can see the descriptive statistics. Okay, remember, since you are going to do multivariate, so you're going to do homogeneity test. Okay, so that is the 2 most important one. You can get the effect size, you can get the observed power, but in this case, I'm not going to do. Click continue, click OK. So you get the results. Okay, so what does it tell you? Okay, so we have trial 1, trial 2, trial 3, trial 4. Okay, we are comparing with the high anxiety group and the low anxiety group. So for trial 1, the number of errors is quite high, 16. trial 2 become less 11, trial 3 become less 7, trial 4 become much lesser, it become 3 and 5. Okay, so what is the interesting one? We have three things that we can look at. The first one that we can look at is overall. So the overall one is a test of between subject effect. So the test of between subject effect, you can see here, it is not significant. So if you take the average of all four, they become not significant. So number of errors between high anxiety group and low anxiety group is the same. Okay, if you look back at the data here, we have the mean of all the errors. Okay, we have the mean of all the errors for trial 1, trial 2, trial 3, trial 4. If we do ANOVA, so we click ANOVA, the usual way we do ANOVA, okay, compare means 1 be ANOVA. Okay, so the dependent list is the errors, the grouping is the factor. Okay, so there's no need for us to do for sort, there's only two groups. Okay, we just want to see. Okay, so you can see here, it is the same, okay, 0.460. So the other one just now, the test of between subject effect, 0.460. So test of between subject effect is the same like doing the average. Okay, you can see there, they mentioned there, they're doing the average of the trial 1, 2, 3 and 4. Okay, so that is the test of between subject effect, which is based on the average. So next one, we are going to look at the univariate and multivariate test. Okay, so you have to scroll up and down to look for the univariate and multivariate test, but never mind, let's have a look at the data first. So you can see clearly the high anxiety group, they started with slightly more errors than the low anxiety group. By the third group, they are already the same, but then they go up again. For the low anxiety group, the blue line, they started lower, but both group, the high and low group, are quite similar. They're not diverging at any point. Okay, so now let's look at the one-way test. Sorry, the univariate test. So the univariate test is there. You can see that as under Mockley test of sphericity. So this one. Okay, so you can see that you got so many tests here. You got the multivariate test up here, and then we got the univariate test here. So this is the univariate test. For the univariate test, you can see clearly that the number of errors are not much different. Okay, they are all not much different. But when we're looking at change over time, they are significant. Okay, so which one to use? We got four choices here. We got sphericity assumed, greenhouse glacier, Unfeld lower bound. So you can see here, to decide whether you can use the Mockley sphericity assumed results, we look here at the Mockley test of sphericity. So we look at the Mockley test of sphericity, you can see the p-value 0.053. 0.053 means you can use the univariate results for sphericity assumed. So sphericity assumed, p-value significant. So what does it mean? It means that there is change over time. So the number of errors becoming significantly less over time between trial 1, trial 2, trial 3 and trial 4. Next one. It is about interaction between number of errors being made and the level of anxiety. They say that based on this, sphericity assumed, it is not significant, 0.368. So what does it mean? It means that as the time changes, yes, the number of errors become less, but the number of becoming less between the high anxiety group and the low anxiety group is similar. They are not different, so that's why they are not significant. Okay, if the univariate test was not valid because of this p-value smaller than 0.05, you should check the box test. So if the box test, the p-value is less than 0.05, you cannot use the multivariate. If it is larger than 0.05, you can use the multivariate test. So this is the multivariate test. You got again another 4 results: Pillai's trace, Ludwig's lambda, Hotelling trace, and Roy's largest root. Which one to use? Anyone can use, but in terms of familiarity, people tend to use the one with the Ludwig's lambda. And you can see the Ludwig's lambda, the p-value, it is not significant. The p-value is significant. Same like the univariate test. So it shows that yes, there is a change, significant change over time in terms of number of errors. It's becoming less and less over time. Next one, is there interaction between error and the anxiety group? Okay, there is no interaction. Why? The p-value is not significant. So both errors change over time, becoming less, but the difference between the high anxiety group and low anxiety is not there. So they both reduce drastically over time. Okay. So if both univariate cannot use, multivariate cannot use because p-value smaller than p than 0.05, then you can use any one of the adjusted value, either Greenhouse-Geyser, Kuhn-Feld, and low bound. Which one to use? Your choice.